Hello and welcome back. Don't forget to like and subscribe and check out the VODs of this computer. I guess I'll do a video recap at some point, but not now. So today it's going to be another shorter stream fixing up. So basically what I've done is, well, this is the CPU is going to be built out along here, right? And this is the first logical operator, which is just a unit that does a logical operation on two binary numbers. And this particular operation here is binary adder. So it performs binary addition on two 16-bit binary numbers. So obviously 16-bit bus comes in here, stores one 16-bit number in there, then the second number that comes in triggers going around here, and that does the addition in here. Then it stores the output there, and then when it's called again, it sends the output single 16-bit number back down this way, and then back towards the memory, which is the memory is way over there. That's the tiny corner you can see there. So what I've just been doing is I've mainly been working on this big junction, right? Because these junctions, these bus junctions, are very labour intensive to build. So I'm trying to, what I want is a standardised design, right, that I can copy and paste, and that's what this should be here. So basically I'll copy from the edge there to like the edge over there. Well, actually, well, it'd be this edge here because this is part of the adder. But today what I need to do is I need to sort out, so the binary adder has to send a status code to the CPU control circuits, which is what that is there, and then there's going to be a whole load more here. And it also needs to send a timing signal, which will also go back there. So the status code will record if the binary adder is waiting for input or if it's waiting to output. So it will record basically whether it's reading or writing. That's what this orange line here is. I swear there's more to it than that. I think it's just pretty simple. I think it's just so the timing of this. Alright, it's not simple because it is simple, but it need to get rid of this first. Naturally, as soon as I have to start thinking, my mind turns to water. It's a hazard of thought. So, as soon as this is triggered, that needs to be triggered. What does this line do, if anything? So I think this line does nothing. Yes, that line should do nothing. And then there is nothing behind me. I actually need a second line, so what, if orange is status codes, what should the timing code be? What should the timing wool colour be? Yeah, probably purple, isn't it? But so red, green, blue are already in use. Black and white are already in use. Magenta or purple, probably purple. So from now on, whenever you see purple wool, it will be carrying a timing signal of some kind, or rather a signal that will be used to time the clock. Like, it won't be sending out regular pulses like a clock, but it will be sending out signals that will be used to iterate the computer, basically. Right, so right now that's rather broken because it needs to be. Alright, so that's fine because it's um no, that's not fine because the signal th, 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 that signal needs to be one way, basically. Because I don't want back propagate. Basically, I want this channel here to turn on only when this top one's on, but currently it'll also turn on when this middle one is on. So I just need to make this one way. So what that means, this turns off that, which turns that. That's that. This is the reads. This is the write signal for this memory address, right? So that if this is on, this signal turns on here, which overwrites this bit here and sets it to 0, and then it's primed for whatever's coming through there to write to it. This signal also closes the switch on the other side. So when that's off, that allows addition to be performed with the number that's coming in here and the number that is going out here, because the read switch is turned on. And the read switch is turned on by, yes. But, right now, if I get rid of this, that overwrites everything. That sends the read switch to here, which turns this on. And turns it on, sends the signal that way. So essentially, right. Where's the right signal? The right signal comes up there. So if I turn that back on, that should turn the right signal on. Now what I don't want, right, what I don't want is addition with zeros coming in from here because it's weighted. So what I do need is I need to break this switch here, basically. Because currently right now it will take in one instruction from the CPU will send a number to here, which will get stored in here. Then a second instruction from the CPU will send a number from here, which will then go here, and simultaneously with that, that will be released into here, and they will be added together and saved in there. But if I have that bit of redstone there that powers that up, when the third signal comes telling it to read to memory, that will still allow the addition of a 0 from here, because there will be no input on this side, right? And then the addition of whatever's in here that go through there and then get around to there, which will overwrite the good result, basically. So what I want to do is break that. And that should be correct. But timing signal wise, I need... So timing signal, I need it to be sensitive anytime. So this magenta signal, purple signal rather, this needs to be on. This needs to pulse on anytime this has finished one cycle of its operation. So anytime it's received a number into here, anytime it's done an addition in there, or anytime it's sent a number out of here, that purple signal needs to pulse. Yeah. Can it be done? Can it be done? So, obviously, when I turn that off, this will cycle back down to the bottom one. Obviously, turning this off is entirely tied to it's entirely tied to the clock anyway, so it seems like it's actually largely meaningless. So that purple line is probably not necessary. Because if you think about it right, naively there's two design options. One is that I have a central clock over there that tells it how long it's going to send signals to this here, and then when it's done it just drops the signals, right? Or I have a line here that comes back and tells the thing that this has finished its operation, right? And then that drops the signal. But I think that second option actually doesn't work because obviously the input, how long this takes is intimately tied to how long that sends the signal here anyway. I think. And also there's actually no way of sensing when it's done. You just have to wait for it to be done, right? There's no, well, I mean, it would take an absurdly complicated system of switches to figure out you need like a whole other computer to figure it out. I think maybe what I've just said may have been incredibly stupid, but let's pretend it wasn't. But this line needs to be tied into so if I turn that off, turning that off should send that down to the bottom. The bottom switch is dormant. Turning it on should send that to the bottom. Now the bottom switch is on. That there corresponds. That there stores the fact that we've now stored a number in this stack here. That single bit there. Now switching it off again. Now this bit here being on tells us that next time it turns on, it's ready to write to that, or rather it's ready to do the addition. But that might be a problem. Hang on. I feel like it's not supposed to. I feel like it needs to stay in that state for. Right, so sending it back to 0. Right, it's in a 0 state. what this means is that no current is flowing here. That is off. What that does mean is when this turns on, that will be ready to write to that, and then it will go into the 1 state. What this means is that this is now writing to this. Oh god. So I just switched it back on, right, which means it's, oh no, it's still in the bottom state. That's because I didn't switch it off. Switch it off, it goes to the middle state. That being on means that will be off. So it receives a signal telling it that there's another number coming. And when it does that, that switch needs to be open, which it is right now. That switch needs to be open, which it is right now. But I think as soon as I close this, that switch closes, which is the problem. Now, it wasn't a problem when I had that other bit of wool there. But that was because it was some... What have I done? What have I done? I swear it was working over here. Yeah, I had the... test rig over here. With that there closed, let's see what happens. So, put one in... Sorry, actually I don't know what state it is in. All off. Right. Just check it's pre-zeroed. So that should write into there, which it does. Now, if I turn this off, oh no, that's not good. So that's what you want. But firstly, why is And then yes, that doesn't change the state, which is what you do want. Like, but that doesn't change the state. If I do that, that will probably turn off, right? No, it doesn't. Okay. Let's try that again now with the other setup. Nothing should. Why is it? That's actually extremely concerning. That's that's graphically and extraordinarily just concerning. That implies that it's that implies that it is essentially there's the carry forward rounding up bit, not rounding up, but when you multiply 2 by 2, you get 4, which pushes you up a binary place, right? And you need a carry bit for that, and that propagating up like that implies that there's an issue with the carry bit, which would be, I mean, I tested it going down. Maybe that. Also, why is that on? Oh, that's on because this is on. Right. So this should, yeah, this is just writing to that. Okay, so um, what I'm getting from this is I may not have designed this with four settings in mind. Because this setting just performs the addition and then outputs the number. Whereas I need an extra cycle to perform the addition, then store the number, so it can be output later. Whereas I guess when I built this, I thought it can just do the addition and then output the number straight away. Let me just double check. So 0 everything. Um, oh, now that's not supposed to be on. Why is that on? I guess normally it is supposed to be on. And I also guess it doesn't matter because that will power down. I mean, I think that doesn't matter, but I think it doesn't matter, but it is a little concerning. Um, so to fix that, I would need to put another NOT gate there. Obviously, when I was designing it, I was expecting this signal to be on, and when this signal's off, that's on. Something like this. What? What is this red? Is this like a bug in Minecraft? Like, why is that red? Why is that wool conducting redstone? What the, what the, what the dickens? Also, have I just permanently broken this redstone? Currently in the off state. That is a truly bizarre redstone interaction. Is that replicable? Yes, yes it is. that's good to know. First things first, I need to build another level on that, on this guy here, on this guy. Um, yes, and technically that is a broken mode because it's yeah. So I just need to add another level, and I need to add. I need to add that redstone back, and then I need to double check the memory address iterator, see if it has this problem too. Ay ay ay. Just paying my stupid tax for the. Well, yeah. Hopefully, I'm paying my stupid tax for the whole year. And let's be honest, it's probably just for the next 10 minutes. Now I need to remember how this horrific little device works. So if it goes up, it must come down. Duh. This is probably a very, very inefficient way of doing this. You know, I don't know anything about redstone or computers or design or anything. But what this thing is essentially this thing is sensitive to changes in the circuit. So if a switch gets flipped on or off, currently this can record that happening 3 times. So it can record essentially it records a cycle of 3 switches on and off. So it'll record when it gets turned on, when it gets turned off, and then when it gets turned back on again. Yes. And then when it gets turned off again. But what I want it to do is record when it gets turned on, then turned off, then turned on, then turned off, and then turned on again. Right, so I need to add one more cycle to this. Now, if I remember correctly, this guy just comes straight up unaltered. So what I want is for when this is on, it needs to turn the other layer off. The next layer off, right? So that's that wire is slightly energized, isn't it? No, it's not. Okay, so this wire turns off when the other wire, when that turns on. Which means that I need... Firstly, I can do this. This is a quick and dirty hack. Bit like me. So this line goes around the outside here, 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 and here. Um, so this needs to feed into a... That goes like that, rather. Comparator. Like that. And this comes around there like that. So when that's on, that should switch the lower layer off. Ah, yes, that's a... Currently that's all initialized off. That should turn the bottom one on. Does. Turning that off should turn the middle one on. It does. Top. That one's not on, neither is that one. Then this should turn the second to top one on. Does. Right. And this should turn the top one on. Which it does not. Hang on, does it turn on when I... Oh no, it won't, naturally. naturally it won't. I might have to put another layer on top of this one, to be honest. Or, well, hang on, I might not be thinking about this clearly. I might not be thinking about this clearly at all. I might not need the extra layer. Full stop. So if there's no signal out of here, there's no signal out of there, but there is a signal out of here. Right. No, 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 no. No, unfortunately that can't work. Question is, can I make it to record when... no, it can only record... It has to record being flipped on and off. It can't just record when it gets turned on, because it has to know it's in an off state. So I can't make that more efficient, so I do need a fifth layer. But first I need to make this layer work. Help it wasn't raining at night time in Minecraft. Oh, right, okay. Records it being turned off, goes to layer 2. That records it being turned back on, goes to layer 3 or 4 for whatever reason. Oh yes, that's why, but why did it... How does the... See, this signal here is supposed to stop that turning on. This signal here stops the signal going that way, but it does not stop the signal going that way. Which means this is backwards. Which is slightly inconvenient. Firstly, maybe I can get it to work if I go this way. Oh, right. Put that going that way. Put that going that way. That means that... Yes, that should work. Okay, now it's broken. Why has it started skipping the middle layer? And what's it actually powered by right there? Oh, I see, that's why. Naturally, if I just put that there, that will fix it. That should turn the bottom one on, which it does. Turn the middle one on. Second, the bottom one, which it does. Should turn the third one on, which it still does not. So that signal there turns that off. Yeah. So the so that's energized just slightly. Except it's not. So you need to switch on that. Just imagine my poor computer trying to calculate the signals whirling around in this intricate spiral. Why wouldn't it just put them straight? I think that's how it works, right? So I need to put a NOT gate here. Like that. There, that should work. Some happy little NOT gates. Oh yes, I broke that, didn't I? I'm starting to think I need to put that NOT gate the other way around. So like this. Oh, thank God. It should send it to the top layer. Which it does not. Because it runs the kill switch before it can get to that NOT gate. Actually, no, it doesn't. It's because it's this. It's funny, there's a symmetry to this and there's a logical order into it, but in my mind it's like each layer is custom and I haven't figured out what the logic, even though like I've literally repeated the same pattern over. Oh, I'm being stupid, I'm being very stupid. Oh. Now I've just disorientated myself by moving the camera around. So this does present a slight problem. See if I can reroute that. I need a kill switch there. But it can't be that switch. works out a little too conveniently, I think. Yes, it does work out just a little bit too conveniently. Well, I know what I can do. Not that. What I can do is something a little bit like this. Experts are describing it as possibly the ugliest bit of redstone they've ever seen. Oh, this is just horrific. I hate it. I absolutely hate this. Oh, it's gotten so ugly. And probably slow as well, right? Like, this whole contraption might add, like, a decent bit of latency. Because it's got to wait for it to cycle to know where it is in the cycle. What it comes down to, though, is that the number... So... Obviously... 2 bits, right? 2 bits of information can store 3 states. So I could, and I'm trying to store 6 states. To store 6 states, you need 3 bits of, I'm trying to use 5. That does imply I'm being inefficient. But I suspect that the contraption required to store those states and interpret them as a binary number would be much more complicated. But yes, in theory, I'm using 6 bits to do something that should be possible with 3. A little concerning, perhaps. At least I think I understand the pattern now. So, what was it? this is the feedback loop. So it essentially needs a feed forward loop, may as well come up here. But no, because so this here needs to turn it off. I think this needs to come up here instead, as far away from that as possible. Oh God. Right. Some dark little thoughts there. How does that go around here? So this is the switch that alternates on and off depending on whether this. So this will tell it if it's a. So this line here tells it if it's a switch that is storing a state that is off, as in it's a state that's been turned off, or if it's a switch that's storing a state that's been turned on. And this one is storing a state that's been turned on. So what that means is that it needs to have a NOT gate with this. So it's the happy little NOT gate. Right. And then it needs to feed back down. So that should turn that off, yes. Now that all darn well ought to work. If I've been switching my comparators on when I should be switching them off this entire time, I don't know. So, yes. So currently that state is on. That state turns on. But that state stays on for some reason unknown. why is this on? So that's 2 from that, and that's 1 from that. Oh, naturally, yes. Mm-hmm. Now that should work. Greatly expanded and uglified. Oh. Oh. That was honestly a lot harder than what I was planning to do in this stream. It's funny, it's only been an hour, but it's really exhausting. Right, anyway, it's not going to fix itself, so what I need is when it's in this state needs to be the read-write state. Get rid of that. Get rid of that. And then when it goes into that third state, it just writes. So that should now work. Oh boy, I'm tired. I wonder how people who know about computers and know about Minecraft build computers. I mean, I do know about computers, I just don't know about chip design. It's an interesting question. It must look radically different to this, probably. Um, Firstly, let's just test this. Sorry, I'm sundowning is what I'm doing. Excuse the morbidity of the phrase. So, that can be broken. Right now, this should work. Let's just check this. This register is. That's what you want right now. So when I zero it, that should turn off. Zeroed. It doesn't actually matter that it's storing stuff in there. It's just that matters. I thought I fixed that. Doesn't my little apparatus here fix it? Oh, hang on. It's broken beyond belief is what it is. No, it's not, but it is broken. That layer. Oh right, that's why. For some reason, it is not returning to the base state. Top layer is on. That layer's off. That layer's off. That layer is off. That layer is on. So, I must have missed a feedback mechanism somewhere. This is getting so unwieldy. This is just... Oh, like this. So if it's 3, it's fine because going from this layer to this layer. Um, Hang on, why does that work? In that state, it is pumping down there, which is turning that off. Right. When I turn this on, there's nothing turning it off. Oh, now this is broken. This is really broken. Something has gone terribly wrong. Um... Yeah. Stick a fork in it, it's done. What state is it even in? So, top one is on, the middle, that one's on, that one's... off. That one's on. Is it just... is it getting like a, some kind of armadillo pattern going on here? So it might just be that there is a spare degree of freedom knocking around in the system that I need to... No, not a degree of freedom, that's a very stupid thing to say. Please forgive me. Oh, hang on, I know why. I know why. Or at least I sort of know why. I think I know why. I think I need to add an AND gate. That should be a nightmare. So basically, as soon as this turns on, it turns that one on. Which is not good. But I'm going to have to call it here because my brain is gone, unfortunately. Which is annoying because I wanted to go on for another hour, but it is what it is. My mind has turned to water. So thanks for watching. Don't forget to like the video. Check out the other pod.